Today we are going to see the software engineering life cycle, various life cycle which we are going to talk about. The main issues are discussion of different life cycle models and maintenance or evolution. So this is what life cycle is, and I'll not say not this life cycle because this is the life cycle. This baby is what we call as a software. So there are various phases of software. First, it incept means it is created, and the ideas behind its creation are being formulated, and then we make that software with certain predefined rules, guidelines, and there are various life cycle depending upon the uh, software or the product, the skill required, the efficacy, the technology involved. All these they will give rise to the life cycle model you choose. So let us start. Software development projects, they are large and complex. See, for a software like for a program like Fibonacci series, or say you are trying to make a factorial program, you don't need this software development life cycle. A phased approach to control is quite necessary. If you are developing a large product or large software, then there has to be a phased approach. That means you need to have different phases, and these phases should be well connected, well organized, and this is very necessary. Then the traditional models are actually document driven, like waterfall model. We'll talk about that. So they were document driven, means there is a new pile of paper after each phase is completed. We're not saying that the pile of paper are unnecessary, but pile of paper are necessary in latest technologies or latest development life cycles. The documents, they are not very much encouraged, but it should be there. Evolutionary models, this recognize that much of what is called maintenance is inevitable. Of course, changes are part of life. Changes are part of software product also. So maintenance is inevitable. But latest fashion is agile methods and extreme programming. Agile methods XP. This is extreme programming. Lifecycle models can be explicitly modeled in a process modeling language. So we have various languages also in which we can easily model these models. This is a simple life cycle model for any beginner. Like you are provided with a problem. There is something called as requirements engineering. First, you need to know what the user wants, or what are the requirements, and how you are going to approach. Then the requirement specification is created. After this requirement specification is created, you design. Now your design means you are making a framework of what you are going to make. So once this design is being completed, now you implement. You implement means on the basis of the design, you code or you make program, and then the system is created. After the system is created, that is, you have well coded according to the design which were made with respect to the requirement specification. Now the system needs to be tested. Okay, you have made something and it should be free from errors. It should be something that the user would like, and frequent problem the user would not like it. Then you will have a working system. Now your working system is there. You what you do, you deliver it. You deliver it, and once you deliver it, then you maintain. Maintenance means there are various type of maintenance. So you maintain it means you try to make it worthwhile. Actually, you have made it worthwhile here itself, but there are certain changes which would be required, and you do it every now and then. So there are something you need to really think of. Why does the model look like this? Means there are various uh, diagrammatic view that I'm going to show you. Why should a model look like this? Then is this how we go about the model? So we can start with a simple life cycle model. That is, it is document driven, it is planning driven, and heavyweight, right? And sometimes you require really heavyweight document and planning because your software is something like that. So once the milestone means you reach here, then you go along, then you reach here, then you again proceed, you reach here. These are the milestone. So milestone are reached if the appropriate documentation is delivered. That is, once you are you have created this requirement specification, you say that the requirement specification part is complete. Once you create the design specification, then you say the design specification is complete. When you code it or you program it, you say that my program is complete or code is complete. Then you test it. Once you create the test document, you say that testing is created. So it increases the visibility. See, it increases your visibility. Okay. So much planning upfront. Often heavy contracts are signed. So you need to plan upfront, well planned. Rigorous planning is required if you are working with the heavy contracts. But the problems are, they are not so much problem. But problems are always there with every nook and corner in your life. So feedback is not taken into account. This may be a problem. Or maintenance does not imply evolution, right? This is our first model, life cycle model, the basic model, which is our waterfall model. In this waterfall model, first of all, we have requirements engineering. As I suggested, we have requirements engineering. You create requirements here. Then you design your software. So you create your design specification here. Then you go for implementation. And this implementation, what you do? You actually make your software, make or create, right? Then you come to testing. Here what you do? You do testing. Means whatever you have made, you test them. The various strategies of testing which we will be talking about in the later sessions. Then we maintain. Once you deliver it, you have tested. Now you need to deliver it and then you maintain it. So you maintain it through some, the various maintenance aspects are there. There are 4 types of maintenance: preventive, corrective, adaptive, and perfective. We'll be talking about this. This is another waterfall model. How this model is being tested. If you have a requirement engineering, then you design, then you implement, and then you test. Now every time you need some feedback, right? What happens in your previous model? What was there? This is like a waterfall. You go from this side, water falls from here to here. Water cannot go up front because of gravity. So this is what waterfall model is all about. But there is a variation in the waterfall model now. Now you can give the feedback also. Now from one phase you can go back to another phase. From implementation you can go back to design phase. Now this is important because once you can't go back, then if you have reached the testing phase and if there is a problem in design, how you are going to actually get rid of those problems? Or if you are at testing phase and you find that required engineering problem was there, then what you are going to do? So you have to have a path to go back. So this is what this waterfall model is all about. Then there is a certain variation of waterfall model. We call it as a V model. Okay, this is our V model. As you see, this model looks like a V. This is a V model. This is a V model. In this V model, the major thing is all the parts or the phases, they are linked with certain type of testing. So when you do the requirement testing, then once you are first of all we come to the design coding part. So coding part we design because coding has come from design only. So once you design, unit testing is done at this stage. Then you integrate. First you create the different modules, and you unit test them. Then there are various modules, you combine them and you test them for integration. And once you have combined all the modules, you do the acceptance testing, or you can say a level ahead of the system testing. This is the V model. So waterfall model, now it includes the iteration and feedback also. Iteration and feedback and validation. Very, very important part is validation and verification. That is, validation means are we building the right system, and verification means are we building the right step. And this is done after each step. After each step means after each phase. After each phase, you check for validation and verification. And the user requirements are fixed as early as possible. The problem is of the waterfall model, this is too rigid, far too rigid. And developers can't move between various abstraction levels. There are various levels. Now, how to move from one level to another? This is the problem with the waterfall model. This is the activity versus phase. Like you have activity called, or say start with the phase. You have design phase. You have implementation phase. In this design phase, you have implementation or unit testing. Implementation, unit testing. Integration, implementation, unit testing. Also, in this design, you can have these testing. So there can be different phases also, and in terms of these phases, you can also apply certain activities that can be testing activity, and of course we are talking about the verification validation also. See, now these are the percentage of values, like when you are trying to at this design phase, is this design phase, you are talking about the activity of design, so that will be around 49.2%. Just taking an example, while you are implementing, the phase is implementation, and while you are implementing, that will take around 17.3% of time, and the integration testing, when you are integrating, the integration testing will take 26.1%. Right. So these are the values which can be taken into account, that at each phase how many activities are there, how many activities are going to be performed. So let us talk about the, so in this lightweight or agile approaches, agile means fast and flexible. This means that it is flexible. So we have prototyping, incremental development, RAD or DSDM. We'll talk about RAD and DSDM, rapid application development, etc. So these are the lightweight or agile approaches, which includes the extreme programming, XP. What is the agile manifesto? What do we say when we talk that, okay, we are talking about the agile manifesto? So individuals and interactions, our processes and tools are very necessary. This is what is given the major concern or consideration. Working software is important over the comprehensive document. Pile of papers which we talked about is not necessary, because we want the software to be working. The customer collaboration over contract negotiation. Why to negotiate? Means rather than contract negotiation, let us collaborate with the customer. Let me have this customer always with us. Responding to a change over following a plan. Means if you have a step plan and you are following it, and changes are inevitable, you cannot just stop the changes. So whenever change is there, rather than following a plan, we can respond to the changes. Then comes the prototyping. What happens in prototyping? Requirement elicitation is very difficult. Now, if you have a software, some agency want to make a software. That agency or those people are not even aware of what they want. They are saying, okay, this kind of thing can be done, but they are not aware, or neither they are having any technological background. So they are not able to present you with the exact requirement. So in this case, software is developed because the present situation is unsatisfactory right now. But the desirable use situation is as yet unknown. Neither you know nor your agency who has given you the product or project making is aware. So prototyping is used to obtain the requirements of some aspects of the system. So you make a prototype working system, not with all the functionalities, but a showcase. So prototyping should be a relatively cheap process. We use rapid prototyping languages and tools. Not all functionality needs to be implemented, and production quality is not required. Here you don't see the quality. You see that what is available with you. But this is because the software is not like hardware. You make a hardware, you can present it to the agency. But what about the software? You cannot present it. You have to make some of the other formation so that they can really appreciate it. So prototyping as a model of requirement engineering. What happens here? First, what we do requirement engineering, design, implement, and testing. Right? Now we again in this case go to this phase. Right? Again and again. And we iterate through this prototyping until our requirements are very clear. Then we go to, once these requirements are done and they are freezed, means now you are aware what you are going to make. Then you go to the design. There's design, then implementation, the testing, and the maintenance. So in prototyping, we call it as a throwaway prototyping. This is the nth prototype. N means you do certain iteration, that is make prototype. So you need to make, say, n prototype. This is followed by a waterfall-like process. Once you are aware and once you make your requirement clear, then you go for a waterfall-like process. So this is evolutionary prototyping. The nth prototype is then delivered. So what are the pros and cons of these two approaches we have just seen? Prototyping, the advantage is the resulting system can be seen well in advance. Means you don't have to wait till the testing process to be over. User needs a better accommodator, because user say 2 requirements sometime, then add 3, then add 5, then add 2 more. So all these requirements are being taken care. The resulting system has fewer features. Problems are detected earlier. Now you make a prototype. Some problem is there. You find, okay, this is the problem. Then you just remove that problem. So the problems are detected quite earlier, before you have actually made the actual software. The design is of higher quality because the design is getting proliferated. Means the level of design is emancipating every time or increasing every time. The resulting system is easier to maintain. The development incurs less effort. Why? Because at the first iteration, you required, say, few people to work upon it. Then at second, again few. So at nth, you have already done this, so you are pretty confident. You are confident. You are aware. Now at that nth level, there will be no kind of barrier because you have already done those hard work earlier. But the disadvantage is the resulting system has more features. Why? Because nobody is satisfied. They would always want this plus this plus this. The performance of the resulting system is worse. Why? Because once you are making different, every time you are making different system, means every time you are giving rise to a prototype. Now it may happen that you don't have that much time of checking the efficiency. The design of the is of less quality because requirement is being freezed. Requirement is not clear. So when you design at a certain requirement addition, you need to change the design. So design changing, that may be ad hoc. The quality may be less. The resulting system is harder to maintain. Why the resulting system is harder to maintain? Because you rather go for bug fixing, not prevention of bugs. These are bugs. So the prototyping approach requires more experienced team members. Why? Once you have prototype, okay, now this prototype some people have worked. Another prototype, you need those people who are here, who are there, because they can really make the software better. So you require more experienced team. The recommendations on prototyping is the users and the designers must be well aware of the issues and the pitfalls. Both of them, the users as well as the designers. Use prototyping when the requirements are unclear. Only when your requirements are unclear, then only go for prototyping. Prototyping needs to be planned and controlled as well. This is not a haphazard way. Prototyping is also a sequence type of a phase, life cycle phases. Then we come to the incremental model or incremental development. A software system is delivered in small increments, thereby avoiding the Big Bang effect. Small increment means you make a software with basic functionality, say X functionality. Then you add in the next version, you add 2 more features. In next version, you add 1 more feature. You add 3 more features. So every time you increment it. Means I am saying that this is already a software. This is not a prototype. This is actual software. So the waterfall model is applied in each phase. The user is closely involved in directing the next steps. And incremental developments, it will of course prevent the over functionality. What we are going to do in the first way, you give the basic functionality. Then the functionality which are actually required or actually desired, they are only added. I am just saying 2 or 1, right? This can be very less, but quite less than what is given by the over functionality. Then we come to rapid application development or RAD, rapid application development. So this is an evolutionary development with time boxes. Here you have in RAD you have these time boxes or TB. So fixed time frames within which activities are to be done. That is why it is a rapid application development. Time frames is decided upon first. We decide it earlier itself. Okay, in the beginning itself. Then one tries to realize as much as possible within that time frame. Say for 1 month or say 15 days or fortnight. And other elements are, first of all, you have JRD. JRD means Joint Requirement Planning. And Joint Application Design, JAD. Workshop in which the user participate. That is how you make a rapid application development. The requirements prioritization is through a triage. Development is a SWAT team. What is SWAT? Skilled worker and advanced tool. First of all, you need workers who are skilled and the tools which are quite advanced. Then there is another model called DSDM. DSDM is Dynamic Systems Development Method. DSDM. This is number 1 RAD framework in UK. Right? DSDM. Dynamic Systems Development Method. The fundamental idea is fixed time and resources, like we just studied in the time boxing. So first we fix time, the resources in the form of time box, and we adjust the functionality accordingly. One needs to be a member of this DSDM consortium also. What are these DSDM phases? First is your feasibility. That is, you deliver, or this feasibility delivers the feasibility report, an outline plan, optionally fast prototypes, say few weeks. Then we do the business study. That is, we analyze the characteristics of the business and technology in workshops. This is delivered, it will deliver the system architecture definition to us. Then we go for the functional model iteration. This is again a time box iterative incremental phase, and it will yield the requirement. Then we design and build. So these are the important phases: feasibility, business study, functional model iteration, and then we design and build the iteration. Then we implement. We transfer to the product environment, actual product environment. So in DSDM, what are the practices? Active user involvement is imperative, is required. The team should be empowered. There has to be a frequent delivery of the products, frequent delivery. The acceptance is determined by the fitness of the business purpose. And again, DSDM has iterative and incremental development. All changes are reversible. This is very important. It is not that the changes have been made and they cannot be reversed. The requirements baseline at high level, and testing integrated in the life cycle. So testing is integrated all phases. There is cooperative approach shared by the all stakeholders, and it needs to be essential. Not only some few people, but all the stakeholders. Then we come to the XP, that is our extreme programming. What is XP or extreme programming? X and P. Extreme programming tells everything is done in small steps, very small steps. So everything is in the small steps, very small steps. The system always compiles. We always compile, we always run. Extreme programming. Clients are considered as the center of development team. Developers have same responsibility with respect to the software and the methodology. So there are various practices of XP, extreme programming. First, whole team, that is the client is a part of the team. Metaphor is common analogy for the system. The planning game is based on these user stories. So XP take it the requirement as, or the planning as, the user stories, and they work on these user stories. This is a simple design. You just design it as simple as possible. Then small releases, 2 weeks, small releases. Then customer test. Once you release it, customer would test it. This is important in XP. Customer is going to test it. Then pair programming. Two people are going to sit together. So if somehow this guy makes some mistake, he is ready to help him. And the problems, because one person gets biased and he is not even, we say 1 and 1 becomes 11. Test driven development, that is the tests are developed first. Design improvement, that is refactoring, is done whenever required. There is collective code ownership. Everyone is the owner of the code. Continuous integration, system always runs. And their sustainable pace means there is no overtime. And coding standards are followed. So these are the practices which makes this XP or extreme programming so famous and so widely used. Then we come to RUP. RUP is Rational Unified Process. So RUP is Rational Unified Process. This is complement to your UML. UML, Unified Modeling Language. This is an iterative approach for object-oriented system. And it strongly embraces the use cases for modeling requirements. So in modeling requirements or requirement specification, etc., you apply or you use cases. As we said, RUP is nothing but the complement to the UML. This is the UML tools and clear case, they all are supported. So RUP is tools. The tools are being used and they are supported. So what are the phases of RUP? There are various phases of RUP. First is inception, then elaboration, then construction, and then transition. So we'll see about the figure just now. Let me explain it to you. So we start, you can remember it by IECT: inception, elaboration, construction, and transition. So in inception, we establish the scope, the boundaries, the critical use cases, the candidates architectures, the schedule, and the cost estimates. In elaboration, you make the architectures. Foundation of architecture is done here. You establish the tool support and you get all the use cases. In the construction process, this is the manufacturing process. One or more releases are being created. Then transition, you release it to the user community. Often you can have several releases. So this is the two-dimensional process structure of RUP. As I suggested, this is inception, this is elaboration, IECT, inception, elaboration, construction, and transition. In this, there are various workflows. This is an organization along content. We have business modeling, requirement, analysis and design, implementation, test, deployment, configuration and change management, project management environment. So all these are there. Okay, whichever workflows we follow or we talk, these are always there in all our these software models, right? So this is initial phase, elaboration 1, elaboration 2. You can have various elaboration. You can have various construction, and you can have various transition also. This is our organization along time. What is the differences for developers? Agile. Agile means knowledgeable, collocated, and collaborative. Heavyweight, plan-driven, adequate skills, access to external knowledge. What about differences for customers? We have seen differences for developers. Now differences for customers. Agile means dedicated. A customer has to be dedicated, knowledgeable, collaborative, representative, and empowered. While heavyweight means he has the access to knowledgeable, or he is knowledgeable, collaborative, representative, and empowered customers. Differences for requirement. In Agile, largely this is emergent or rapid changes are there. Heavyweight, early knowledge, largely stable. And what are differences for architecture? Agile means designed for current requirement. Heavyweight means designed for current and also foreseeable requirements. What are the differences for size for Agile and heavyweight? Agile is smaller teams and products. Heavyweight means larger teams and products. I'm not saying that this is smaller teams and smaller product. This is smaller team and products. Differences for primary objective in Agile. You want everything to be rapid. Heavyweight, you need a quality or high assurance. So this is the advantage of screen wiper. As you can see that whenever you have some water coming, if this is not there, wiper is not there, you'll not be able to drive through the rain. Then we come to model driven architecture, MDA. This is model, this is code. You make first the model and then you code, and model is implemented into the code and then you maintain the code, right? So what is the essence of MDA? Essence of MDA is platform independent model. You need to have a platform independent model. The model transformation and refinement has to be there. This resulting in a PSM, that is platform specific model. What is the maintenance and evolution? Because maintenance is the part which is very important. There are certain observations. Systems are not built from scratch. You already have a system. Now you need to maintain it. So there is a time pressure on maintenance always, because you cannot just let your software to be there, down. The 5 laws of software evolution is law of continuum changes, increasing complexity, program evolution, invariant work rate, and incremental growth limit. This is illustration. Third law of software evolution. This is how it evolves. These are the system attributes. They grow with the time. Software product lines. Developers are not inclined to make a maintainable and reusable product. It has additional cost. People are not worried about this. The viewpoint is changed somewhat. If the product family is the focus of attention rather than producing a single version of product. So there are two processes are resulting here. That is the domain engineering and application engineering. Process modeling means we may describe a software development process or parts thereof in the form of, say, program. For example, this is a function. This is how you model the process. This is the STD of review process. How you go along. See, the coding is ready, you submit. See, then you review. This is the part of review. You prepare, ready, do, done, make report ready. This is ready for the next step. So this is very important that whatever you make should be reviewed every time. This is Petri net view of the review process. From coding, from management. This code is ready, now the schedule is ready. You hold the review here. Then the code and the time. Then the update. Then you revise the code and then you go to the next step. This is the Petri net view of the review process. Then the purposes of post-process modeling is it facilitates understanding and communication by providing a shared view of the process. So it supports the management and improvement. So it can be used to assign task progresses, and identify the trouble spots. It serves as a basis for automated support, usually not fully automatic. Caveats of process modeling. What are the caveats of process modeling? Not all aspects of software development can be caught in an algorithm. A model is a model, of course. Thus, a simplification of reality. This model is a simplification of reality. And progression of stages differs from what is actually done. So some processes tend to be ignored. For example, learning the domain. There is no support for transfer across projects. So what we have seen today is traditional models focus on the control of the process. There is no one size fits all model. Each situation requires your own approach, its own approach. A pure project approach inhibits reuse and maintenance. There has been quite some attention for process modeling and tools which are based on such process models. So this we took a general idea about the software development life cycle, and we'll be talking about this life cycle model in detail wherever it requires. Thank you so much. Take care.